Hello everyone. In this video, we are going to solve the problem number 1.58 from Irodov, and that is related to kinematics. So let us first understand the problem and then we will solve the problem step by step. A solid body rotates with a constant angular velocity omega naught is equal to 0 0.5 radian per second about a horizontal axis AB. So let us say this is a body which is rotating about the axis AB and with the angular velocity of omega naught is equal to 0 0.5 radian per second. At the time instant of t is equal to 0, the axis AB starts turning about the vertical with a constant angular acceleration of beta naught is equal to 0.1 radian per second square. So let us say this is another axis which is the vertical axis, and the axis AB is rotating about the vertical axis with the angular acceleration of beta naught is equal to 0.1 radian per second square. Now we have to find the angular velocity and angular acceleration of the body after t is equal to 3.5 seconds. So first of all, we have to understand that about this particular axis the body is rotating, and initial angular velocity, if we talk about, let us denote it as this particular axis is 1 and this particular axis is 2. Let us say the initial angular velocity omega 2 naught is equal to 0 about this particular axis, and we have to find out the angular velocity at a particular time instant about this particular axis by using the kinematic equation. So we can write omega 2, that is the angular velocity at the time instant of t about this particular axis, is equal to omega 2 naught plus beta naught into t, and this is 0 because it is starting from zero angular velocity. So we can write omega 2 is equal to beta naught into t. Beta naught is given as 0.1 radian per second, so we will get 0.1 into t, and we have to find at the time instant of t is equal to 3.5 seconds. So we will get angular velocity is equal to 0.1 into 3.5, that is equal to 0.35 radian per second. So this is the angular velocity we got at the time instant of t is equal to 3.5 seconds about this particular axis. Okay, now about this particular axis is rotating about this particular axis. So let us say at the time instant of t, axis AB has rotated by an angle of theta. So let us say it has rotated by an angle of theta. At the time instant of t, the AB will become something like this. And let us assume the coordinate system, that is x is in this particular direction, y is the vertical direction, and z is this one. So the body is rotating about the vertical axis in the xz plane. If we talk about the angular velocity about axis AB, so that is constant but the magnitude is keep on changing. So we can write omega 1, that is the angular velocity about the axis AB, that we can write it as 0.5 radian per second, and the direction at the time instant of t will be in this particular direction, which is always perpendicular to the vertical axis because this particular axis is always moving in the xz plane, right? So if we want to find out the resultant velocity, that will be equal to omega 1 square plus omega 2 square under root, because these two axes are mutually perpendicular to each other. So from here we will get 0.5 whole square plus 0.35 whole square under root, that is equal to 0.61 radian per second. Now in the second part of the problem, it is asking to find the angular acceleration of the body after t is equal to 3.5 seconds. Okay, so let us say at the time instant of t, it has rotated by the angle of theta. So now the angular velocity is in this particular direction with the constant angular velocity magnitude, that is equal to 0.5 radian per second. Okay, and this particular angular velocity will have the two components. One is in the x direction and another will be in the z direction. So we can write omega 1 vector is equal to omega naught cos theta I cap plus omega naught sin theta into k cap. Okay, and omega naught is fixed, that is 0.5 cos theta I cap plus 0.5 sin theta k cap. Okay, and omega 2 we have found out at the time instant of t, that is equal to beta naught into t j cap. So if we write down the angular acceleration, that we can write it as d by dt of total angular velocity, that is equal to d by dt of omega 1 vector plus omega 2 vector. So we can write d by dt of omega 1 vector is 0.5 cos theta I cap plus 0.5 sin theta k cap plus omega 2 vector is beta naught t j cap. Okay, let us differentiate this particular expression. So we will get 0.5 times differentiation of cos theta is minus sin theta into d theta by dt times I cap plus 0.5 times differentiation of cos theta sin theta is cos theta, and the derivative of theta is d theta by dt k cap plus differentiation of beta naught t is beta naught, because beta naught is constant and the differentiation of t is 1. So we will get beta naught into j cap. Okay, and if we see here, theta is rotating in the xz plane about y-axis, so we can write d theta by dt is equal to omega 2, that is at the time instant of t, and omega 2 is 0.1 into t. So let us substitute it here. So we will get 0.5 minus 0.5 into d theta by dt is omega 2, that is 0.1 t. So we can write 0.1 t into sin theta I cap plus 0.5 into 0.1 t into cos theta k cap plus beta naught is equal to 0.1. So that is 0.1 j cap. So now we have to find the angular acceleration at the time instant of t is equal to 0.35 seconds, sorry 3.5 seconds. So let us substitute it here. So we will get minus 0.5 into 0.35 into sin theta I cap plus 0.5 into 0.35 plus 0.1 j cap. So from here we will get minus 0.175 sin theta I cap plus 0.175 cos theta k cap plus 0.1 j cap. So the magnitude of angular acceleration we can find it as minus 0.175 whole square times sin square theta plus cos square theta plus 0.1 whole square under root. So from, as sin square theta plus cos square theta is equal to 1, so from here we will get 0.2 radian per second square. So this is the value of angular acceleration we got and the value of resultant angular velocity. So I hope the entire procedure is clear. Thank you.